Our planet Earth is heating up, fast. Scientists call this climate change, and it's a massive challenge. We need bold, even wild ideas. Some look to new technology, others to lifestyle changes. But what about a truly radical idea? Imagine detonating a massive nuclear bomb deep under the ocean. Not for war, but to fight climate change. Could such a drastic measure actually work? It sounds like science fiction, but one thinker believes it's a real possibility, a potential solution to a global crisis. So, let's put on our thinking caps. Is it genius, madness, or just desperation? We need to look at the science, understand the risks, and consider the alternatives. Fasten your seatbelts. This is going to be explosive. We're diving deep into a controversial idea. Could a nuclear blast really help cool our planet? Let's find out. What is climate change, and why is it suddenly at the center of every major conversation about our future? It's not just a buzzword, it's a crisis that's already affecting millions of lives around the world. Earth's natural thermostat is broken. Temperatures are rising faster than ever before in recorded history. The main culprit? Us, human activity. We're burning fossil fuels like coal, oil, and gas every day to power our homes, cars, and industries. These activities release greenhouse gases, especially carbon dioxide or CO2, that trap heat in our atmosphere. It's like wrapping the planet in a thick, invisible blanket that keeps getting heavier and hotter. More CO2 means more heat, and the consequences are huge. Glaciers are melting at alarming rates, sea levels are rising, and entire coastal cities are under threat of flooding. Extreme weather is becoming the new normal. Stronger hurricanes, longer droughts, fiercer wildfires, and deadly heat waves are happening more often. Farming, water supplies, and wildlife are all at risk. Our food systems and natural habitats are being pushed to the brink. This is a global problem that demands urgent action from every country, every community, and every individual. We're pumping out CO2 much faster than nature can absorb it, overwhelming the planet's natural balance. The result? A planet in crisis, with disasters piling up and the future looking more uncertain than ever. If we don't act soon, the damage could be irreversible, changing life on Earth as we know it. That's why some are considering extreme solutions, ideas that once sounded like science fiction. The stakes couldn't be higher. Our choices now will shape the world for generations. We need to fully understand the problem before we look at wild fixes or risky experiments. Climate change isn't waiting for us to catch up. The clock is ticking, and every moment counts. Can we find a solution in time? That's the challenge facing humanity right now. And it's why ideas as radical as the nuclear bomb plan are even being considered, despite the risks. Let's take a closer look at how this controversial plan is supposed to work, and what it could mean for our planet. Who came up with this nuclear bomb idea? Meet Andy Haverly, a man whose name is about to become synonymous with one of the boldest climate proposals ever imagined. Unlike most climate scientists, Haverly's roots are in engineering and the study of complex systems. He's spent years solving problems that others thought were impossible, always searching for the next big breakthrough. Haverly is an independent thinker, someone who thrives on challenging the status quo. He's not afraid to ask the questions that make others uncomfortable, and he's constantly looking for unconventional solutions to the world's toughest problems. When he looked at the mounting evidence of the climate crisis, he realized that current efforts, no matter how well-intentioned, simply aren't enough to turn the tide. The scale of the problem demands something far more powerful, something that can match the intensity of the crisis itself. That's where geoengineering comes in. Massive, deliberate interventions designed to alter the Earth's climate system on a global scale. It's a field filled with both promise and controversy. Some of the ideas being explored are almost science fiction, giant mirrors in space to reflect sunlight, or fertilizing the oceans to boost carbon-absorbing algae. But Haverly's proposal stands out. Even among these radical concepts, it's on another level entirely, pushing the boundaries of what we think is possible. He asked himself, what's the most powerful force humans have ever harnessed? The answer, of course, is nuclear energy, capable of both immense destruction and, potentially, unprecedented change. But what if, instead of destruction, a nuclear explosion could be used for good? Specifically, to remove vast amounts of CO2 from the atmosphere and help reverse global warming. Haverly's plan is as daring as it is controversial. Detonate a nuclear device underwater, targeting special rock formations that could trigger a chemical reaction to lock away carbon dioxide. It's a radical departure from the wind turbines and solar panels we're used to seeing, an idea that could change the entire conversation about climate solutions. Unsurprisingly, it sparked intense debate and concern among scientists, policymakers, and the public alike. The risks are enormous, but so is the potential reward. Is this the breakthrough the world desperately needs, or a disaster waiting to happen? The line between innovation and catastrophe has never been thinner. Haverly's idea forces us to rethink the limits of human ingenuity, and the lengths we're willing to go to save our planet. But before we rush to judgment, let's take a closer look at how this audacious plan is supposed to work, and what it could mean for the future of climate action. Could this be the game changer that finally tips the balance in our favor? Or is it just a dangerous distraction from the real solutions we need? The answer may shape the fate of our world. Let's break down the nuclear plan, a radical idea that's both fascinating and controversial. Imagine using the immense power of a nuclear explosion, not for destruction but as a tool to help the planet. It sounds like science fiction, but let's see how it might work. How could an underwater explosion possibly help our climate? The answer lies in chemistry, geology, and a bit of bold thinking. First, you'd need a massive nuclear device, far beyond anything ever used in warfare. We're talking about a bomb of unprecedented size and power, designed specifically for this purpose. The plan involves placing this bomb deep on the ocean floor, targeting areas rich in basalt rock. These locations are carefully chosen for their unique geological features. Basalt is key because of its special chemical properties. It's a volcanic rock, abundant in minerals that can react with carbon dioxide. When the bomb detonates, it pulverizes the basalt into countless tiny particles, creating a massive underwater debris field. This explosion creates a huge surface area with millions, if not billions, of rock fragments suspended in seawater, dramatically increasing the potential for chemical reactions. Here's the climate-fixing part. These tiny basalt particles are highly reactive. Their fresh surfaces are primed to interact with the ocean's chemistry. They contain minerals like calcium and magnesium, which are essential for the next step in the process. When these minerals are exposed to seawater, they react with dissolved CO2, pulling it out of the water and locking it away. The reaction traps CO2, turning it into stable carbonate minerals like limestone and other carbonates that settle harmlessly on the ocean floor. With less CO2 dissolved in the water, the ocean can absorb more from the atmosphere, acting as a giant carbon sink. In theory, this could help lower atmospheric CO2 levels, potentially slowing climate change on a global scale. It's a bold shortcut to a natural process, one that usually takes thousands or even millions of years now sped up in an instant. But can it really work at the scale we need? Scientists are still debating the feasibility, and there are many unknowns. And what about the risks? The environmental consequences of such a massive explosion could be severe and unpredictable. The science is intriguing, but the consequences could be massive, affecting marine life, ocean chemistry, and even global weather patterns. Let's look at the scale of what's being proposed. The area affected would be enormous, potentially altering entire ecosystems. Just how big would this bomb have to be? The answer might surprise you and raises even more questions about safety, ethics, and the future of climate intervention. How big is big when it comes to this bomb? Haverly's plan calls for a device far larger than any used in war. For perspective, the Hiroshima bomb was 15 kilotons. The Tsar Bomba, the largest ever, was 50 megatons, over 3,000 times Hiroshima. Haverly's idea might require something on that scale, or even bigger. The goal pulverized billions of tons of basalt to create enough reactive surface area. This isn't just a big engineering project, it's a planetary-scale intervention. The energy involved is almost unimaginable. Multiple massive explosions might even be needed. The risks and logistics are staggering. It's not just about building a bomb, it's about changing the planet itself. Could we even control the outcome? The sheer scale makes this idea both fascinating and terrifying. Is it even possible to pull off safely? Or is it just too much power for us to handle? Let's dig deeper into why basalt is so important. Why basalt? It's one of Earth's most common volcanic rocks, rich in calcium and magnesium. When basalt weathers, these minerals react with CO2 and water, forming stable carbonates. This locks CO2 away for thousands of years, a natural carbon trap. The problem? Natural weathering is painfully slow. We're adding CO2 much faster than nature can remove it. Pulverizing basalt into fine particles speeds up the process dramatically. More surface area means faster reactions and more CO2 trapped. It's like turning a sugar cube into powder. It dissolves much faster. The bomb idea is a form of enhanced weathering. But is speeding up nature with a nuke really the answer? Let's look at the dangers. Detonating a giant nuke underwater comes with colossal risks. The most obvious radiation. Fallout could contaminate vast ocean areas, harming marine life and entering the food chain. The shockwave would devastate fragile ecosystems, coral reefs, deep-sea vents, and countless species. Marine mammals could be killed instantly, and entire habitats destroyed. There's also the risk of triggering underwater earthquakes or landslides. That could mean tsunamis, giant waves threatening coastal cities. The unintended consequences could be catastrophic. We simply don't know enough to predict all the outcomes. Is any potential benefit worth these risks? Using nuclear explosions for peaceful projects isn't new. In the 1950s and 60s, the US ran Project Plowshare, exploring nukes for digging harbors and canals. The Soviets had similar programs. These tests created massive craters, but also radioactive fallout and public backlash. Environmental damage and health risks ended these projects. Haverly's idea hasn't been peer-reviewed or widely accepted by scientists. He's not a climate scientist by training. That doesn't mean he's wrong, but it does mean we need skepticism. History shows that nuclear solutions often create more problems than they solve. Should we repeat those mistakes? So, is this nuclear plan a brilliant fix or a desperate gamble? Some see it as bold thinking for desperate times. Others are horrified by the risks. Radioactive contamination, destroyed ecosystems, unpredictable disasters. The main pro, it could, in theory, lock away huge amounts of CO2, but the cons are massive. Irreversible damage, ethical questions, and unknown consequences. Is it genius or a dangerous distraction? The climate crisis demands bold ideas, but also wisdom and caution. This plan sparks a crucial debate. How far are we willing to go to fix our planet? What price are we prepared to pay? The answers aren't easy, but the conversation is essential. Our future may depend on it.